So in this video we are briefly going to cover random number generators in NumPy. I will not talk about all the different ways we can generate random numbers in NumPy. However, the focus is more on understanding random number generators and getting an idea why they are useful in practice. So maybe let's start with a simple example. So let's just draw a random number or random sample. Let's first import NumPy, and then there is this random module in NumPy which contains a lot of different functions for drawing random numbers. Here's a nice overview. It's an older documentation, but I couldn't find the equivalent in a newer documentation that has such a nice list of different things. For example, using random.rand would draw random samples from a random uniform distribution given a certain shape. So if we provide 2 and a 3 here, it will generate a 2 by 3 dimensional array with random numbers from a random uniform distribution. There are also other ones here. For example, the random function random which contains random floats in the half open interval between 0 and 1 and so forth. So there are many different types of functions you can use. Also, you can draw random samples from different distributions here. So for example, there's one way using the random.randn function to draw samples from a standard normal distribution. There's also another one, I think, right here. Same thing. Also, drawing samples from a random normal distribution. If you want to draw samples just from a normal distribution, you don't want to rescale it manually, you can just directly use the normal function here, which gives you the mean, standard deviation, and the size. I think it should be the standard deviation. Could be the variance, but I think this is the standard deviation. Yeah. Okay. So let's draw using a simple approach, a random sample using randn, and we will just draw a random sample of 10 values. Yeah, this is nice. However, you can see if I execute it again, these numbers will change, which is useful in practice in many applications. But in machine learning, if we want to, for example, generate random numbers for shuffling, or if we want to just shuffle an array and we implement some functions to test our implementation, sometimes we want to always get the same results, and that guarantees us to have a reproducible code, which means that if we send our code and our example execution of that code to another person, the other person who would run your code would get exactly the same results. And this is often very useful in certain situations where you have reviewers, you submit a paper and they run your code, and ideally they should get the same numbers you get, right? So if everyone gets different numbers every time you execute it, then it's kind of hard to tell what's going on. So in order to do that, to guarantee that you always get the same results, you can set a random seed at the top of your notebook, for example. So here, this number is totally arbitrary. It's just some number. And here now, when I execute this, I get these 3 values, for example. After setting the random seed, if I execute it again, it will always be the same 3 values, right? However, if I draw another sample here, this will of course be different because it's still a random sample. It's just like if you execute the code over again, it will be the same numbers drawn from the random uniform distribution. Yeah, so why and when is that useful? If you think back of our KNN notebook from lecture 3, I showed you how to shuffle an array, and there, for example, it would be useful to set a random number seed. So every time we split the data set, it's the same split. So if someone wants to compare our method or the KNN method with a different KNN method, it would always generate the same split of the data set if we use the same random seed before we shuffle it. Or maybe just to give you an intuitive example here too, let's consider a simple, let's say KNN implementation. So if we have a KNN classifier, neighbors, I think. Yep. in scikit-learn. And let's just say we want to test it for some reason. We want to implement a test. We want to test it on some random data, and we generate labels. Let's say we have 50 examples from class 0 and 50 examples from class 1. So it's just a quick way of creating a label array with random labels. I mean, the labels are not random, but we will associate random values to that. So we can then, for example, draw a sample. So in NumPy, in scikit-learn, our convention is usually we use Y for the class labels and X for the features. So we have, let's say, 100 training examples corresponding to our labels here, and then 2 features. So this will be random data. And then let's say we can fit our k-nearest neighbor classifier. Okay. And fit, right? X, Y. And then let's say we have our scoring function. Well, it's like computing the accuracy. So we get an accuracy of 66%. Now if we do that again, our accuracy goes here to 68. So this is kind of fluctuating. So if we want to stabilize it, we would of course have to use our random seed. We would insert that usually at the top of our notebook or code. So if this would be the top of our notebook, it would be going right here before we use the random function. So it will always be the same value now. And now we can, for example, let's say we develop a unit test. I'm just showing a very simplified example. We can include a test like this, and then this should always pass until maybe I change my random number generator and this doesn't work anymore. Or if I draw, so this would work, and then I draw another random sample, because the second random sample is different. This is not true anymore, so that will give us an error. And the same, so this is a very trivial example, but the same issue exists if we shuffle our data set, for example, using the train test split method in scikit-learn that I introduced in the k-nearest neighbor method notebook. But yeah, let's not get into too much detail about k-nearest neighbors. This was just an example showing you how a random number seed and a random number generator works. Personally, I always prefer to use a random state object in NumPy. This is an object that, or it's its own random number generator, because usually when I write code, I have different positions where I use randomness, and this allows me a little bit more fine-grained control over where I want my randomness. So if I have a very long code example, let's say I want my randomness because I want to collect a sample of something, just a large random sample, and I only want the shuffling of the training set to be fixed, but every time, let's say I execute my code, I want different results. So in that case, I would only set the NumPy random seed for the specific part in my code, for example, the train test split. So where I would, or for example, when I draw random indices to shuffle arrays, I would only use that there. And this random state allows me to do that. So if I use this one, it won't, I will show you maybe here, it won't affect anything we do with NumPy random.rand. So if I set this random seed here, it will every time still generate different numbers. So this one is not affected by this object, because if we want to use this random number generator, we would have to use it directly. So here we are calling a NumPy function. So the function is rand, which is contained in the NumPy random module. And here we are initializing an object from the random state class. And then we are calling a method rand on this object. So we are calling it here. So every time I'm executing this, I will get the same results. And this is the same as doing NumPy random dot seed So it's the same thing. You can also see the numbers match. However, I can have multiple of these objects. In particular, I can have infinitely many of these. And I can use them at different places in my code. So this one gives me always the same results, but then if I call it twice, of course, it will also, the second result will be different from the first result, right? So this will always give me the same results, but this one will be different from this one. Yeah, this is usually how I prefer using a random state in my code. However, there's also a newer version of that. So this is because I'm old school. Back then there was only random state. However, nowadays the NumPy community recommends the new random generator. So if you like, you can read more about that here. For this class, for our class, it's not necessary. Actually, I kind of even prefer the old one because it generates results similar to using the function. However, yeah, I should probably recommend using the new random generator in your projects if you like. I think the improvement is just the way they generate random numbers, so the algorithm that is used for generating random numbers. In practice, for our simple applications, you won't notice a difference because in our case, it doesn't really matter how the random numbers are generated. For us, it's more important that we get consistency and reproducible code, and this is more due to setting a random seed. In any case, this one will give different numbers than, let's say, calling this one. So be aware of that. It's not like a one-to-one mapping like these two. This one will generate different values. And it's just using a different method for generating these pseudo-random or random numbers. So in code, number generators are not truly random, they are usually pseudo-random, but yeah, that would be a very long video to explain that here at this point. All you need to know is there are different methods for generating random numbers. It doesn't really matter which one you use, especially not for this class. The only thing that matters is having a random seed. So for example, if you submit homework and you get certain results and I execute the homework to check if your results are correct, for example, it would be great if I get the same results as you get, right? So in that way, what's more important here is setting a random seed. Okay, so but that is all I wanted to say about random number generators. They are not super important, like what type of random number generator you use, but using a random seed is important.